Hi, I'm Mr. Kenyanola, and today I'm going to teach you about these things right here. No, not the L symbol. No, you're not a loser. Not left, but actually the opposite of those two words. Well, if you look at this line right here and this line right here, what do they make? A right angle. So we're going to talk about lines that make right angles, and those lines are called perpendicular lines. So, repeat after me, okay? Even if you're by yourself, say it out loud. Perpendicular lines. So, perpendicular lines are lines that really do make an L, but make right angles. So, perpendicular, right angles. Perpendicular, right angles. So, perpendicular lines, lines that make right angles. So what's the deal with perpendicular lines? This is what's in this video. Well, two facts about perpendicular lines. You just learned one fact that they make not L's. Well, yeah, they make L's or upside down T's or T's, but they really make 90-degree angles, so or right angles. And so we have one fact. I'll teach you about the other fact about perpendicular lines, and I'll show you how to prove that two lines on the coordinate plane really are perpendicular, or two lines on the coordinate plane really do make 90-degree angles. So let's get our notes out, and in your notebooks, write the word perpendicular lines. And if so, write it out, and I'll show you a symbol for perpendicular. So let's use this red pen. If you don't want to write perpendicular, I know it's a long word, and you're probably low on ink, okay, or low on graphite on your pencil. Okay, this is the symbol for perpendicular right here. So it's an upside down T. It's two lines that make right angles. So if you don't want to write perpendicular, you can just write the symbol, and that's perpendicular. So fact number one, as we just learned, are lines that make right angles. And there's a symbol for angles, so I don't want to write angles, so I made the symbol. And just so that we remember, right angles are 90 degrees. Okay. And so fact number two, we'll get to that in a second. So there's fact number one. They make right angles. They make 90-degree angles. So what we're going to do is, let's look at all these weird shapes and symbols. And what I want you guys to do with these real life examples, when I say pause, not right now, but in a few seconds, when I say pause, I want you guys to, on your computer screen, I guess, take a pen that you could probably wipe off the ink from, and I want you guys to draw some right angles where lines are perpendicular. So this line right here will be perpendicular to this line, so put a right angle symbol right here. So this is the symbol for right angles, so that means this line and this line made a 90-degree angle. You guys got that? So there's probably a few more here that you could see. So press pause when I say it again, and then unpause it once you're all done. All right, so press pause. All right, so now you've unpaused, and I'm sure that yours looks way different than mine because yours is all marked up. So here's another pair of right angles that are pair of perpendicular lines that make a right angle. Here's another right angle, another one. So perpendicular line, perpendicular line. And now there's a little curve right here if you see that. So, but if you didn't see that little curve, then yeah, you could draw a right angle saying that this line is perpendicular to this. Let's look at this right here, this Grecian temple, I guess, or an ancient building. This line, come on, things don't float inside of buildings, so this roof wouldn't be floating upon these pillars. So I'm going to assume that this pillar goes and touches this roof, so this would be perpendicular to this. This would be perpendicular to this, perpendicular, and we could say that all of these are make right angles. Okay, so assuming that a roof doesn't float on top Okay, it's sitting on that. Okay, and let's look at this one. What do you think these three shapes are? Well, this is a triangle, this is a triangle, yeah, this is a parallelogram. If you got that, then good, you're advanced. But in real life, I would guess this is a tent. And this would be the post holding up the tent. And here's the opening of the tent that you would walk into so you could go to sleep at night. But this post right here would be perpendicular to the ground. And look at that. It makes the perpendicular symbol that we just talked about. So we can draw that right angle right there and another right angle right there. Here's a ticket stub. Let's see if we get some of them. So this is so here's an upside down T, or there's that perpendicular symbol. So that's a right angle. That's another perpendicular line, and up here also. Okay. Here's a piano. Any of you guys play piano? I play the trumpet. Looks totally different from this, but this key has some perpendicular lines. So if you got all of these over here, even the black keys right here, and the ivory keys right here. Okay, so this line is perpendicular to here and here. Okay, so you guys get the point. And this one umbrella, yeah, I guess this part right here is a little curved, but if this one wasn't curved, then the line of this thing that holds up the umbrella for rain or sun, okay, will be perpendicular. If this isn't curved, but if it is curved, then we'll just take that away. Okay, so perpendicular lines, they're in real life. So when you guys go out, and there's even a perpendicular line right here. Look at that. So these lines right here on my piece of paper are perpendicular because they make a 90-degree angle. So they're everywhere. So once you guys go walk around your house, you guys go outside, you're gonna start noticing them, or you should notice them. Okay, so that's fact number 1 about perpendicular lines that make 90-degree angles. Fact number 2 deals with this. Okay, so lines that are on the coordinate plane. Okay, these two lines are perpendicular. Okay, if you don't want to take my word for it, let's take this protractor. Okay, a protractor is like a ruler for angles. It measures angles. So you see that 90 right there. So what I'm going to do is I'm going to prove to you that this line is perpendicular to this line. I'm going to put my protractor right there. And you guys see that? So here's that red line right here, and then there's a blue line, and it touches the 90 degrees. So yeah, it measures up. So these two lines are perpendicular. But what if you don't have a protractor? And what if the test says, are these two lines perpendicular without using a protractor? How can you prove it? Well, I'm going to show you. So what I want you guys to do is, when I say pause, find the slopes of these two lines. Okay, find the slopes. Okay, press pause. Pause. All right, unpause. So let's start off with this red line and see if you guys got the slopes correctly. I'm going to start off with this point right here and to this point right here. It looks like this line is positive because it's going uphill. So I'm going to draw the line for my fraction, and it goes uphill. So the rise over run. So it's going to rise 1, 2, and then run 1, 2, 3. So the slope for this is 2/3. Okay, and then the slope for this one, I'm going to start here, and then it looks like the line intersects this point right here. It already looks like this line is negative because it's falling down, or it's going downhill. So I'm going to put a negative, and then it goes down 1, 2, 3. So -3, and then it runs 1, 2. Okay, so the slopes for these two perpendicular lines, 2/3 and -3/2. Do you guys see that? Do you notice anything? Okay, I'm not going to tell you yet because we're going to look at 2 more examples. All right, so press pause, find the slope for these two lines that are perpendicular. Oh, if we did that, see, look, they're really perpendicular. But what if you didn't have that? Find the slope. Pause. Unpause. So this line right here, the blue line is negative. The slope is negative because it's going downhill. So I'm going to write the negative already. And it goes down 1, and then it goes over 1, 2, 3. So negative 1/3 thirds for this line. And then for this red line, looks like it starts from here and then it intersects at this corner right here. And so it's positive, and it goes up 1, 2, 3. So it rises 3 and it runs 1. Okay, so look at that. The slope for this is negative 1/3, and the slope for this is 3/1. The previous one, the slope of this is 2/3, and the slope for this one is negative 3/2. Do you guys notice anything? What's the deal with the slopes? Still not going to tell you. I'm going to show you one more example just to make sure that you guys really get it. So press pause and find the slopes. All right, unpause. So for this blue line, it looks like this line intersects at this corner right here and goes all the way through this corner right here, which is the origin, and it's a negative because it's going downhill. It goes down 1, 2, 3, and it runs 1, 2, 3, 4. Negative 3/4. And this line right here, the red line, is positive, so I'm just going to draw my little line that makes it a fraction. It goes from this point to this point right here. So it goes up, rises 1, 2, 3, 4, and 1, 2, 3, so 4/3. All right, so these two lines are perpendicular. Look at these two slopes. One's negative, one's positive. One's negative, one's positive. What? One's negative, one's positive. But something else is different. This is 2/3. This is 3/2. They flipped. 1/3, 3/1. 3/4, 4/3. So, what is true about these two slopes? Well, one is positive, one is negative. So that means that the slopes are opposites. Okay, they're opposites because if one's positive, then the other one's negative. And then also, if you look at the fraction, the numerator and denominator is flipped, so that the denominator is now the numerator, and the numerator is now the denominator. They flip the numbers. They flip the fraction. So they're opposites, and because they're flipped, that word is reciprocals. So opposite reciprocals. Slopes are opposite reciprocals. One's positive, one's negative. One's positive, one's negative. One's positive, one's negative. So I told you guys at the beginning, 2 facts about perpendicular lines. Slopes are opposite reciprocals. Okay, and just for example, so let's put a little e.g. This means for example in Latin maybe, or some, I don't know. For example, if the slope of one line is a/b, then the slope of the line that's perpendicular, so we're going to use this perpendicular symbol like we said earlier, would be negative b/a. Okay? Alright, so slopes are opposite reciprocals and make right angles. So press pause and memorize those 2 facts. Pause. Okay, unpause. So perpendicular lines. When I say perpendicular lines, you say make right angles, and slopes are opposite reciprocals. Perpendicular lines, make right angles, opposite reciprocal slopes, or slopes are opposite reciprocals. Perpendicular lines, make right angles, slopes are opposite reciprocals. Right angles, slopes are opposite reciprocals. Perpendicular lines. Make sure you guys memorize those 2 facts, okay? So let's get some practice, okay? So if you see 2 lines and the question says, are these 2 lines perpendicular? Then find the slopes. If they're opposites and reciprocals of each other, then you could say, yes, they are perpendicular without having to use one of these, okay? So let's get some practice. So write the slopes of the lines that are perpendicular to lines that have the following slopes. So we don't have a picture, we just have slopes. So for example, if one line's slope is 7 over 2, then the line that's perpendicular to its slope would be negative, because this is positive, so it's opposites. And then reciprocal, the fraction is flipped or switched. So positive is negative, and then reciprocal flipped. Okay, so press pause and find the slopes of the perpendicular lines for these remaining 5 problems. All right, unpause. So this one would be positive 3 over 5. This one would be negative 9 over 1. Okay, so if we had a line with a slope of 1 over 9, then its perpendicular line would be negative 9 over 1. This one, well, let's make this into a fraction. This is a whole number, so let's make it 2 over 1. And its perpendicular slope would be negative 1 over 2. Let's make that look like a 2. Let's make this into a fraction to negative 3 over 1. And then perpendicular would be positive 3. Oops. Saved it. Okay, so positive 1 over 3. Okay, and then this one is probably the trickiest one. Let's make this into a fraction, and then its perpendicular slope would be, well, this one's positive, so the opposite would be negative, and then reciprocal will be 1 over 1, which is just negative 1. Okay, so the slope, the opposite reciprocal of 1 would be negative 1, and this one we could simplify this to just negative 9. So there you go. So slopes of perpendicular lines are opposite reciprocals. One's positive, one's negative, and they are flipped. So there you go. Remember, 2 facts about perpendicular lines. They make right angles, and the slopes are opposite reciprocals. There's perpendicular lines. Have a great day.